What makes a confidence interval wider or narrower? Let's explore the three key factors. Recall the margin of error formula. M equals Z star times sigma over root n. Three things control the width of a confidence interval. First, the confidence level, which determines Z star. Higher confidence means a wider interval. Second, the population variability sigma. Larger sigma, wider interval. Third, the sample size n. Larger n gives a narrower interval. Let's look at each factor in detail. Watch how sample size affects the confidence interval width. Starting with a small sample of n equals 25, the interval is quite wide. As we increase n to 100, the interval gets noticeably narrower. At n equals 400, it is narrower still. And with n equals 712, the interval is quite precise. Larger samples give us more information and tighter estimates. Now let's compare confidence levels side by side. Using the same data with n equals 712 and sigma equals 40. The 90% confidence interval is the narrowest. The 95% interval is a bit wider, and the 99% interval is the widest. More confidence costs you a wider interval. There is always a trade-off between precision and confidence. We can also determine the sample size needed for a desired margin of error. The formula is n equals Z star times sigma divided by m, all squared. For example, with sigma equals 15 and 95% confidence, a margin of error of 5 requires about 35 subjects. A margin of 3 requires 96 subjects. And a margin of just 1 requires a whopping 865 subjects. The takeaway, cutting the margin of error in half roughly quadruples the required sample size. Finally, there is a direct link between confidence intervals and hypothesis testing. A two-sided test at significance level alpha rejects the null hypothesis when mu0 falls outside the corresponding confidence interval. For example, H0 says mu equals 180. Since 180 falls outside the 95% CI, we reject at alpha equals 0.05. But 180 is inside the 99% CI, so we would retain the null at alpha equals 0.01. To wrap up, larger samples give narrower, more precise intervals. Higher confidence requires wider intervals. Greater variability also widens the interval. You can calculate the needed sample size for a target margin of error. And confidence intervals connect directly to hypothesis tests. If the null value falls outside the CI, reject the null.